I'm going to be showing you a demonstration of how rocks are formed using crayons. We are going to start with igneous rocks. I'm going to take a fire torch here, which will act like the magma melting the igneous rock deep below the surface. As you can see, the rocks are melting slowly. As they start to cool, crystals will form. Crystals can be short, fine grains or long, coarse grains based on the length of time it takes for them to form. The longer the time they are cooling, the longer and coarser the crystals will be. The shorter time they are cooling, the shorter and finer the grains will be, and sometimes very hard to see. Here are some examples of igneous rocks. Igneous rocks form when magma or melted rock form inside the earth and cool and harden. The magma may come from volcanoes or just be trapped below the earth's surface. If they form above ground when the magma erupts from a volcano as lava, they are extrusive igneous rocks. If they form deep inside the Earth's crust and are exposed at the surface by the overlying rocks wearing away, they are intrusive igneous rocks. The crystals found in igneous rocks have angular shapes. They have not been worn like sedimentary rocks or squished like metamorphic rocks. Now I'm going to show you how sedimentary rocks are formed using crayon shavings. I'm going to place this book over it along with a heavy weight and apply a lot of pressure. As you can see, all the little sediment pieces are cemented together to form sedimentary rock. After years and years of even more pressure, just imagine what it would look like. Here are some examples of sedimentary rocks. Sedimentary rocks are formed from pieces of pre-existing rocks or dead organisms. If you've ever been to the beach and grabbed a handful of sand, you've held sediment. Sediment carried by the wind or water deposits in layers. Once it becomes cemented together, it forms sedimentary rock. As such, these rocks are the best places to search for fossils. Finally, I'm going to demonstrate how metamorphic rocks are formed. Now, technically, I could have placed the first two rocks, igneous and sedimentary, on top of one another to create metamorphic rock. But we are going to do this instead to change the chemical composition of the crayon, applying heat and pressure. Now, as you can see, we completely changed the crayon's chemical composition from a solid to a liquid. Just like the igneous rock, as the metamorphic rock cools, crystals form and their size is based on the length of time it takes for them to form. Here are some examples of metamorphic rocks. Metamorphic rocks started out as some other type of rock, but have been substantially changed from their original igneous, sedimentary, or earlier metamorphic form. Deep inside the earth, or where tectonic plates meet, intense heat and pressure can change rocks into entirely new metamorphic rocks. The conditions are so extreme, they can change the rock's texture, color, and the shape of its crystals. Even the rock's minerals are broken down and new ones are formed. This can happen to any rock, igneous, sedimentary, or even other metamorphic rocks. It's all a part of the Earth's rock cycle. This is the rock cycle. The rock cycle is used to explain how the three basic rock types are related and how Earth processes, over geologic time, change a rock from one type into another. Plate tectonic activity along with weathering and erosional processes are responsible for the continued recycling of rocks. When magma cools down, igneous rocks form. If heat and pressure is applied, they turn into metamorphic rock. If there's weathering and erosion, it turns into sediment. Metamorphic rocks experiencing weathering and erosion also turn into sediment. With compaction and cementation, it turns into sedimentary rock. Metamorphic rock can come from igneous rock that has undergone heat and pressure, or sedimentary rock that has undergone heat and pressure. which changes the chemical composition of the rock. If metamorphic rock melts and turns into magma, the process starts over again.